Hi guys, audio is going to be a bit out of sync, completely out of sync, because the microphone was broken when I made this video and I didn't find out about it till afterwards. I'm talking today about collecting like terms, which is something that we do often in algebra. If I have a look at what we've got there, I've got 5a plus 3a. So I could think about that in terms of 5 apples plus 3 apples. I'd know I'd have 5 plus 3 apples, I'd have 8 apples. Or albatrosses or anything else where the A is just a pronumeral, it stands for something that I don't know what it is. It could be the number 1, in which case I'd have 5 times 1 plus 3 times 1, I'd have 8 times 1. We use a specific strategy when we work with like terms. So the first thing that we need to do is identify the sign or the operator in front of every part of the expression. So there I've got 5a plus 3a. There's an invisible plus in front of the 5a, and I'm going to add that in. So that's step 1. The next step is to identify that they are like terms. So when I'm looking at this, I'm looking for the algebraic part, the pronumerals. They have to be exactly the same. So right there I'm talking about apples, 5 apples and 3 apples. If it was 5a plus 3b, they're not like terms. I've got apples and bananas. They're not the same thing. So I have to be really careful. So I'm identifying my like terms and I'm going to draw a box around them, and you'll see why we do this later in the next example. But I've got 2 like terms, and they're like because they're all lots of a. Next, I'm going to pull my coefficients out and I'm going to collect them. So 5a plus 3a, when we were talking about apples, we said it was 8 apples. We did 5 plus 3. So I'm going to bring my 5 and my 3 out the front. 5 plus 3 apples. And I've collected the coefficients. The next step, I evaluate. So I do 5 plus 3, and that's 8. So I get 8a. So that's calculating or evaluating the answer. So those 4 steps should help whenever we're collecting like terms. So if we look at a more complicated example now, here we've got 3a plus 2ab squared plus 5a take ab squared. So I'm going with my first step as before, and I'm identifying my invisible positive at the beginning of the expression. So there was nothing in front of that 5 before, so we put a plus. There's nothing in front of that 3, so we put a plus. Now also, I'm looking and I'm noting that each term has a coefficient. So 3, 2, and 5. There's nothing in front of ab squared, so I'm adding in the invisible 1, right? It's not 0 ab squared. That wouldn't be there. It's 1. Whenever there's nothing, we can add in an invisible 1. Okay, so the next step is to identify the like terms. So I can see I've got a's and I've got ab squareds. So the a's, we said 3a and 5a in the previous example were like terms. So I'm drawing a box around them to identify, and note that I'm including the operator or the plus or minus in front of the term in that box. Now ab squared, you might argue that's got an a in it, so it's a like term with 3a and 5a, but it's not. The entire algebraic part has to be identical. So the ab squareds are like terms with each other, but they're not with the 3a and 5a. So now I've done step 2, I've identified the like terms. Now I'm going to add in an extra step where I jumble them all around, and that's the reason why I have included the plus or the minus in the circle or the square, is because when I jumble them around, the sign has to stay with the term. So that negative 1 is going to stay with that ab squared. So the next step is called grouping, where I group my like terms together. So I've written 3a plus 5a plus 2ab squared take 1ab squared. And now I've got all of my a parts together and I've got all of my ab squared terms together. So the next step is to collect coefficients. So like in the previous example, I do 3 plus 5a and then plus positive 2 take 1 ab squared. Now the plus in the middle we leave as a default because you can see in my bracket I've kept the plus in front of the 2 and the negative in front of the 1. So that's collecting coefficients. Now it's time to evaluate. 3 plus 5 is 8. Plus 2 take 1 is 1. ab squared, and I know that I can use that 1, I can let that be invisible and say that it's 8a plus ab squared. And I'm finished. And that's how you collect like terms. So using those 5 strategies in that order, you should be able to collect even the most complex of expressions.